looking at either going from a formula to a name or a name to a formula, there is a systematic way we can do it. Now, part of the problem is that we learned ionic naming, and then we learned how to name acids, and we learned how to name two nonmetals, and then we can throw polyatomic ions in there. So I'm going to kind of make it a little bit systematic, but there's still some things that you're going to have to learn. So if we're looking at a formula, okay, the very first thing I want you to do is look at the first element. Okay, now your element is going to be one of three things. Okay, so either it's going to be a metal, it's going to be a non-metal, or we're going to throw one other odd one in there, hydrogen. Hydrogen is going to be its own category. Okay, so if it's a metal, okay, we will have one set of things we do. If it's a non-metal, there's another set of things we do. And if it's hydrogen, there's a third set of things we're going to do. So we're going to look at that first element, that first capital, and it might have a small letter on there, and determine where on the periodic table it lies. So remember, if it's to the right of the zigzag line, it's a non-metal. If it's to the left, if it's a metal, and then if it's H, it's hydrogen. Okay. So when we do that, first thing I want you to do, if it's a metal, I want you to name the metal. And ask the question, does it need a Roman numeral? If it does need a Roman numeral, put a parentheses there. You don't have to know what goes in the parentheses to know that you need a parenthesis. So that's the first thing we're going to do. Okay. The second thing we're going to do, and now that is going to be the cation, the metal. Okay. Then we are going to name the anion. Okay. Now, if it is, you've got a couple possibilities. If there's only one atom in the anion, one element, I should say, it's monatomic. Okay. So we're going to change the N to IDE. Okay. So that's chlorine, we change to chloride, fluorine to fluoride, oxygen, oxide, sulfur to sulfide. Okay, but if there's more than one element there, then we have a polyatomic ion. Okay. So, and you're going to name it as is. Now, that might be a little tricky sometimes. For example, if you have K2ClO2, we know K is a metal because it's on the left side of the periodic table. We would name it potassium. But ClO2 is not one of the 8 that you were expected to learn, but I know it's one less oxygen than chlorate. So I know it's going to be chloride. So you might have to figure that out. That's not something I'm necessarily going to simplify for you because there's not really a good way to simplify. Okay. So that is be naming. Now we have one little thing hanging there. What if we needed a Roman numeral? Okay. So if you have a parenthesis, you're going to find the charge on the metal and name it and write it as a Roman numeral. For example, I would have a C2 and O3. Okay. So if I'm looking at this, first thing I'm going to do is I'm going to find, okay, Cu, Cu, it's in the middle of the periodic table. Okay, so that's copper. And copper does need a Roman numeral. We know that because it's not in the first two columns, and it's not one of the four that I said don't need Roman numerals. Okay. So I can even put it in there. So if it's in the first two columns for silver, zinc, cadmium, or aluminum, we don't need a Roman numeral. This is not one of those, so it needs a Roman numeral. NO3, we have NO3 memorized yet. Lucas?
Nitrate.
Nitrate.
Nitrate. And not only do you have to know the name, you have to know the charge. What's the charge on nitrate?
3. Negative.
Well, it's -1, and there's 3 of them, right?
Yeah.
That's where you got the 3?
Yeah.
So overall, and I like to write these up here. So if this is a -3, or I can put 3 times -1, either way. What's this have to be?
3.
3 Roman numeral. And how do I say that?
3. 3.
Aye. Pretty cool, huh? Okay, so there's still memory, still have to figure it out. But what if it's not? And we'll get to hydrogen last. But what if it's a non-metal? Okay. We're going to ask a question. First question. And I put the NH4 in parentheses because a lot of times it will be in parentheses, although not all. So if it's ammonium, okay, so if it's ammonium, we're going to name it the ammonium and then name the anion just like we did over here. Okay. So if it is not ammonium and our first element is a nonmetal, and you see it in this class, we're going to use prefixes. Are there exceptions to this? Yes. Will we have exceptions to that in Gen Chem 1? No. Okay. So you will not be expected to name any of the weird ones, just these. By the way, there's also an entire system for naming chemicals containing carbon, which has over 1 million names. By a lot. Those are just the ones that have actually been made, used. There's potentially billions of names of elements or of compounds that you can have. We're not going to worry about that. We leave that for upper division stuff. Okay, so what's the last thing? If it has a hydrogen at the beginning, how are we going to name it? Acid. Okay, so if it's hydrogen, it's going to be an acid. Okay, so if it's an acid, I want you to count the elements. Capital letters would be an easier way of saying it, but count the elements. If you get to 2, you're going to put hydro, the element name changed to ic acid. And you didn't capitalize the A in acid, but I wanted to make sure you could tell it said acid. And if it's 3, we don't put a hydro. We just take, so this is going to be an H plus a polyatomic ion. And we are going to take the polyatomic ion name. I forgot about that thing in the middle here. If it's ATE, we are going to change it to ic acid. And if it's ITE, we are going to change it to OUS acid. Pretty simple, right? So let's do a couple. How do we name that? Well, what's the first element? N. Is it a metal or non-metal or hydrogen? No. So it's not hydrogen, so it's a non-metal. Is it ammonium? No. It's prefixes. So what is it?
Dinitrogen.
Dinitrogen. How many oxygens? Pentaoxide. Don't want to forget that. The first element, we leave the name as is. The second element, we change the N into ID. Okay. You don't have to worry about figuring out which one goes first and which one goes second. There is a method that we use to do that. All right, that's a simple enough one. Let's go for SO4. The easy part is finding it on the periodic table. You have to remember the names.
Iron.
Iron.
4.
Well, it's iron. Well, and it needs a Roman numeral, but we'll get to that. Iron, what's the SO4? Sulfate. And what's the charge on a sulfate?
Oh, -2.
It's a -2. What's the charge on the iron then? I don't remember, +2. I gotta throw a I'm not just being friendly here.
Nitrogen iodide,
Well, if it's hydrogen,
petroleic acid,
it's an acid, right? How many elements?
two,
Two. What do I put first?
hydro,
Hydro.
ionic acid,
Hydro, iodine, change the I-N-E to I-C. So it's hydro. Iodic acid. Sounds fun, right? Okay. So this is, if we get the formula, how do we get the name? Okay. You know what, we could probably do something similar to this of going name to the formula. You just want to take a picture of that or you got it down?
Can you do a practice? Like, it was one that I got stuck on
Yeah.
the sheet. It was NH4 parentheses, 2O.
Okay, we'll do that. What's the first element?
No, how do you say it?
Well,
Pneumonia?
it's an N, right?
Pneumonia.
First element is an N. It's a metal. So is it ammonium?
Yeah.
Yes. So we name it ammonium. And then what's the Ni? What is that? Oxygen. So how do I do oxygen? There's only one element. Right, so I change the end of oxygen to ox.
What's the parentheses and two outside?
Because I need two ammoniums. Okay. And that's why I put the ammonium in parentheses, because a lot of times you'll see it in parentheses, not always. Okay. Now, I don't have enough board space to do formula to name. I'm sorry, this was formula to name to form. Okay, so I gotta erase all this. You ready for me to erase? Yeah.
Could, the sulfide, isn't it like SO3? Right?
Well, okay, so here's the problem.
I'm just curious, even with sulfide, would it still be a -2 charge?
These are two different things. So in this one, our sulfide is SO3 2 minus. In this one, it's sulfur trioxide. So if it's just two nonmetals and there's no charge, it's not a polyatomic ion.
So if there's a metal in it, that's sulfate then.
Sulfide, yeah.
Sulfide, yeah.
Yeah.
Okay.
Okay? All right. So I'm gonna erase and we're gonna go the other way around. So when I do this next part, there is gonna be a point at which we need the prefixes. I'm gonna assume you already have the prefixes down because we did the other part. Okay. So now we have a name and we're looking for formula. Okay. So we're gonna do something kind of backwards from that. We're still gonna look for certain things. So we're gonna start by looking for prefixes. Okay, mono, di, tri, etc. Okay, so if you see prefixes, use them. Okay. So for example, if I say CP 4010, sorry, I went to a different one because if I see, oh, let's do this one. Nitrogen pentoxide, I see prefixes, right? Okay. Nitrogen, what element is that? Prefix and the di means
Two.
two. And oxide is, pent is five. See how hard that is. So with prefixes, we get the first symbol, subscript from the prefix, second symbol, subscript from the prefix. However, beware of dichromate. It has a prefix. Okay. But how do I know chromate is not an element?
You won't find it on the periodic table.
There isn't an element on the periodic table that ends in A. ATE is a ending for a polyatomic ion. Okay. All right. So like all the elements they named after people, they put on the end, like after Seaborg, they called it Seaborgium. Or Niels Bohr, they named it Bohrium. Or Einstein, they named it Einsteinium. None of them end in ATE. And we will see dichromate, at least in the lab in this class. Okay. All right. So that's if we see prefixes. The next thing we're going to look for is acid. Okay. So if you see the name acid, the first thing I want you to do is so you're going to take H plus the element. I'll make sure that doesn't say a T. H plus the element. And then if you need to add a subscript to the hydrogen to balance charges. An example for that would be, oh, we see acid, and we see hydro. So I need hydrogen. Sulfuric, what element would that be?
Yes.
Sulfur, which is an S. What would be the negative charge on an S? -2. So how many hydrogens do I need?
2.
2. So that's what that second word. Now, if we do not see hydro, it's going to be H plus a polyatomic ion. And then again, we would add the subscript to the hydrogen if needed. Okay. Now, if it's and notice that perchlorate ends in what? What's it end in? ATE, right? So you could have chlorate or perchlorate. Okay. So this is hydrosulfuric acid. Okay. And what if I had just sulfuric acid? I see the acid, right? Gonna put the H down. Sulfuric, that comes from sulfurate. Okay, well, there isn't a sulfurate. We have that silly R thing going on in there. So instead of sulfurate, it's sulfate, right? What's sulfate?
So
SO4 specifically. What's the charge on a sulfate?
-2.
-2. So how many hydrogens do I need?
2.
2. And now you see that we have hydrosulfuric acid and sulfuric acid, and both of these exist. And that's why we have to have the hydro on the binary acid group. Okay. So that leaves us most of the compounds that we're. Okay, so we didn't have prefixes. We didn't have the name acid. This is going to be an ion. So it's going to be cation, anion. Okay. So from the name, so we're going to write the formula, which is the symbol for the cation, and then the formula or symbol of the anion. Okay. So for the anion, so the cation is probably going to be a metal or ammonium. They're fairly straightforward. The anion, okay, we are looking for if it ends in ATE or ITE, it's a polyatomic. If it ends in IDE, it's most of the time a monatomic. Now, there are a couple exceptions. There are 2 common polyatomic ions that end in IDE. Which one did we have to know?
Iodine.
Iodine's a monatomic ion. What's a polyatomic ion? Look at your polyatomic ion list. Which name is in IDE?
Hydroxide.
Right. Now, there's also another polyatomic ion. You don't have to memorize this, but if you see it, I want you to be aware that it is a polyatomic ion. That's cyanide. And hopefully you're seeing this, right? Cyanide, CN. Nitro. Okay, so we've got this set of rules. We'll see if it makes things a little bit easier. So let me give you 4 different things to look at. We'll start with I'm giving you names, right? Okay. Try those 4, and then we'll go through it again. Here, I'll even number them for you. Are we about there? Are we still on the first one? Well, let's go through it with you guys. So, nickel 2 carbonate. Prefixes? Acid? What's the cation's formula? And I. Okay, what about the cation?
CO.
Now, at the end of this, we have to balance charges by adding subscripts, okay? Now, the easy way to do that, and I don't know how to put this on the table, but I always put the charges above the name, right? So you just said carbonate was a -2, right? What's the charge on the nickel?
That's a 3?
That's the three, there's three vertical lines there. Sorry. If my handwriting is that bad, but you get the idea, okay? So this is a plus 3. Now, plus 3 and minus 2 are not balanced. Now, just as a hint, if you ever have a 3 and a 2, just do that with them. So 3, 2, and we have. The next one, perchloric acid. Prefixes? Acid? Yes. Ah. Start with an H. Does it have hydro?
No.
No. Okay, so now I need to find a polyatomic ion. Perchloric would come from perchlorate. What perchlorate is? What's perchlorate?
CL.
Well, chlorate is ClO3, so perchlorate is ClO4. Now, it just so happens that chlorate and perchlorate have a charge of a -1. I don't need to add any subscript to the hydrogen for this one because it's already balanced. Trisulfur tetrachloride. Does that have prefixes?
Yeah.
Oh, okay, use them. Sulfur. Tri. Chloride. Tetra. That one's easy if you get one of those, right? Okay. And finally, ammonium nitrate. Prefixes? Acid? What's the cation? NH4. And just so, I'm gonna have to do this later, what's the charge on ammonium? Ammonium is the +1. Okay. And then nitrate. NO3, and it's a -1. So I don't need to add any subscripts for this. Okay,